Good afternoon, everybody, and welcome to the final panel of the day. Breaking Barriers, Innovations, and Challenges in the Aerospace Industry. And I'm very excited to be your moderator for this panel. My name is Philip Perry. I'm Director of Product Management at CAE. And before introducing today's panelists, let me briefly describe CAE. As some of you may know, we're a world leader in pilot training. We train over 135,000 pilots annually. And in the U.S., all the U.S. Air Force pilots and all the U.S. Army fixed-wing pilots at some point in their career come through a CAE-owned training center. Additionally, every 5 seconds, a plane takes off that uses CAE's aviation software. We have achieved that success through relentless investment in innovation. Connecting this all back to the forum's theme, CAE is also the first company in the Canadian aerospace industry to achieve carbon neutrality in 2020. As mentioned by Mayor Gallego in her opening address, we have an ambitious decarbonization plan with efforts that include electrification of training aircraft that will first be deployed here at CAE's Phoenix Training Center. We are also active in advanced air mobility, working on many eVTOL manufacturers through the challenges of aircraft integration as well as associated pilot training. Like many industries, aerospace is undergoing a transformative era, notably with sustainable initiatives and AI to meet the demands of a more efficient, safe, eco-conscious, and technologically advanced future of flight and space missions. Today, to share more about this, I'm pleased to welcome our distinguished panelists who will have an opportunity to introduce themselves and their companies. So please welcome Dr. Anita Gupta, founder and CEO of Hydroplane, Jim Cantrell, CEO of Phantom Space, Sonia Faraz, Vice President Ignite at Lockheed Martin, and finally Todd Giles, Chief Technology Officer at Honeywell Aerospace. So welcome all. This is great to have you all on stage, and maybe we just go a quick roundtable. Introduce yourselves, your company, and some of the challenges that you're working on. Anita?
Hi, I'm Anita Sengupta. I'm CEO and founder of Hydroplane Limited, and we're developing a hydrogen fuel cell power plant for aviation and mobile energy transport. And we're hoping to use green hydrogen as a means of decarbonizing heavy-duty transport in general, and ultimately, hopefully, to get rid of diesel power systems altogether.
Oh, fantastic. Jim.
Yeah, Jim Cantrell. I'm the CEO and co-founder of Phantom Space. We're local here in Tucson, Arizona. We're looking to be the Henry Ford of space by building the next generation of space transportation and constellations.
Hi, I'm Sonia Faraz. I work for Lockheed Martin Space. I lead the Ignite organization, where we do our development and research for all of the next-gen technology. We do tech acceleration, and we also look at new ways to do business with new entrants into the space arena, and also others that have technology that could be applicable to space.
Hey, good evening. Todd Giles, Chief Technology Officer for Honeywell Aerospace Technologies, headquartered right here down the street over by the airport here in Phoenix. For those of you that don't know Honeywell Aerospace, we develop pretty much all kinds of aerospace products. On every aircraft you've probably ever flown on, there's a Honeywell product on it. We've been on every manned space mission since the start of space missions with men on it, men and women on it. And so we are 100% dedicated to decarbonization of, commercial aviation and anything else with respect to that. So we build engines, APUs, avionics, navigation, you name it. We're pretty much ubiquitous across commercial aerospace.
Fantastic. Thank you. Thank you all. And when I first read this panel's outline, I said, how much time do we have? 4 hours or 8 hours? And they said, well, if you can cut it to 50 minutes, okay, that's we'll try. So basically structured along three main themes, but we can roll with that and certainly develop as it goes. Fuel and propulsion systems, sustainable aviation fuel is certainly a big theme. Hydrogen fuel cells, safer propellants, as well as batteries, how that all applies in both aviation and in space. A second segment on economics and innovation. How do we fund this? How do we work differently with government, with other industry partners to get there faster? And finally, looking at AI and other potential innovations that can help transform the aerospace industry. So to kick this all off, let's start with fuel and propulsion systems. There's a lot of hype and publicity around sustainable aviation fuel, SAF as we call it, with increasing emphasis on sustainability. What innovations we see with these and other alternate fuels? Maybe, Anita, you want to start off?
Sure. So it really depends upon the aviation use case. So you may be using a jet aircraft. For a jet aircraft, SAF definitely is the way to go right now. That's the technology that's ready. But if you're looking at other types of aviation use cases, such as vertical takeoff and landing, rotorcraft, any vertical lift application, single engine aircraft, multi-engine aircraft, for shorter regional travel where you're turning a prop, there you can actually shift to alternative, completely emission-free technologies such as battery electrification or hydrogen. And so hydrogen fuel cell has the advantage of having a really high specific energy and a really high specific power, which enables you to essentially get to the same range on these propeller-driven aircraft using hydrogen as your fuel source versus using a hydrocarbon.
Fantastic. Todd, your thoughts?
Yeah, I mean, I think you said it well. It's going to depend on the mission and the use case of the aircraft, the profile, what do you need to do, ranging all the way from battery technology, let's say in drones or shorter range, lighter weight aircraft, moving all the way up to the commercial aircraft we fly in every single day around the world, right? SAF is that near-term technology. From a Honeywell perspective, we have the benefit of one of our other business units develops the technology to produce SAF. So we get to develop the technology to produce it, work with refineries, and then we also do, we have products that burn fuel today, and so then we get to test that SAF and those blends and things like that. So whether it's sustainable aviation fuel, direct combustion of hydrogen, hydrogen fuel cells, batteries, electric propulsion, we are, kind of betting on every single one of those use cases because my opinion and the company's opinion is you're going to need every single one of them to decarbonize.
Yeah, very interesting. I guess there's such a choice. There's almost a buffet menu of different options out there, and ultimately, it's really a function of the use case in which you're going to apply and use that fuel system or that propulsion system. I guess what are the challenges associated with implementing this at a broader scale? Is SAF out there able to supply the world's needs in terms of aviation? Sonia, maybe you can add something to that, or anybody else in the panel, please.
So, I'm a space person, so I'm not going to comment. Let me just be fair about that. Okay.
Very, very good. Well, Anita.
I guess I'd say one thing with SAF, the challenge for any new technology is the cost. So right now, SAF, unfortunately, is a lot more expensive than regular aviation fuel. So that's the reason why, in general, people are loath to accept it. That being said, there are different elements of the aviation sector. For example, business aviation. Business aviation, in some cases in Europe, perhaps they may go out of business if they don't shift to a new fuel type to reduce their emissions. So when there's some kind of motivation to do it, whether it's emission free or because you've got a government punitive measure, that's another way of having that happen. But I would say electric aircraft is also a challenge to implement because you have to have electricity at the airfield and the charging stations at the airfield. And same thing with hydrogen. You have to have the infrastructure at the airfield to support that. So each and every one of them has its own infrastructure challenges and cost challenges, but more people using it, more investment from governments to get that infrastructure going means it's going to become more ubiquitous and reduce the cost. And the ultimate play for hydrogen, actually, whether it's combustion or with fuel cells, is it actually will be cheaper because green hydrogen is produced by electrolysis, which means it's driven by the cost of electricity.
Yeah, and this infrastructure challenge is something that we've heard here today, right, with electric vehicles, about having the charging stations and having that anxiety range of how do you deal with having sufficient infrastructure in place to be able to deal with it. So I guess that's a big aspect. I'd like to shift briefly to astronautics and space missions. I know that's right up your alley, Sonia. I apologize that for a bit earlier. Safety is always key, and what are your thoughts on where these fuels are going and how they can be integrated into the space industry? So, Sonia, over to you.
So from a space perspective, I think we're talking a lot here on Earth on batteries and electrifying, et cetera. And right now, batteries really aren't built for spacecraft. We use the batteries on a spacecraft to store the energy from solar panels, etc. But batteries require a thrust, and there's nothing to thrust off of in space. So what we're doing at Lockheed Martin is we actually have 3 initiatives going on right now to actually harness the power of the atom to really make sure that we're getting rid of fossil fuels, we're being more efficient, etc. So we are looking at nuclear thermal propulsion for a greater thrust in space, fission space power for lunar operations. So maybe you could say that's fission surface power since it's lunar. And also nuclear electric propulsion. And that's just taking that fission space power, amping it up a little bit. It doesn't have as much thrust as NTP does, but it's much, much more efficient. So we're kind of going in a different way, away from batteries, still away from fossil fuels. And the other thing we're really looking at is green propellant. Something that, and when we say green, we mean not as toxic and safer. Because right now, when you want to launch spacecraft, there's a lot of delays, a lot of really important timing because you don't want to fuel up things weeks before launch. So we would really like to be able to use green propellant to fuel up, get ready, and then launch when we want to. And it still be safe for all the operators, still be safe for the launch vehicle and all the spacecraft.
It's interesting. Space really has 2 phases there: that intense thrust of getting to orbit, and then that long distance energy density you need for missions to moon or the moon or beyond. So that's an interesting dynamic there, that you need different fuel and propulsion systems for each of those respectively. And Jim, your thoughts of this with Phantom Space and the work you're doing right now with smaller satellites?
Sure. Well, so I have a background both automotive and space, and I really see space and the industry really the equivalent of about 1915 in the automotive industry. There's a lot of early players. We've been doing it for a lot of years, but really the technology is still very, very young, and there's a lot of room for future innovation. So if you look at where we've come on the fuel side, it was really before my time. We used a lot of acids and a lot of hydrazine and nitrogen tetroxide, very toxic fuels, as was mentioned before. Those are still used on some satellites. So on rockets, however, they were used largely by our ICBMs in the 60s. And the U.S. Air Force went away from that. The Soviets used it for many years. They polluted a lot of places over our years in the former Soviet Union, helping to clean some of that up. And we've gone away from that. We've gone to basically jet fuel and liquid oxygen, which is a step forward, right? Okay. And SpaceX really pioneered a lot of that, going to that. With the next generation, we're starting to see again, we're talking about the large thrust that you see on rockets. We're seeing these guys going to methane and liquid oxygen. So the Starship you see launch out of Texas is methane. It's funny that the industrial methane supply drops to 0 every time they launch one of those.
They take the world's supply in one fell swoop.
Exactly. And here's another thing that's interesting, not a fuel, but the world's helium supply is dwindling. And SpaceX has cornered the market on the helium supply because they use so much of it on their launch vehicles. So we're all looking at alternatives to that. Beyond that, it's as Sonia said that we're looking at more efficient ways to go through space, because you don't need as much thrust there. You need enormous amounts of thrust to lift off. I mean, we're talking hundreds of thousands of pounds to millions of pounds for a launch vehicle, and that's the kind of thrust you need to get that up and above the atmosphere.
That's amazing. I guess another aspect of innovation we'll come back to later is the aspect of simply smaller satellites, right? Because if you're using less fuel, then that in itself is a benefit from a decarbonization perspective as well, right? And that allows a greater flexibility in terms of business models as well. So we'll talk about that a bit later. Let's talk a bit about batteries and fuel cells. And we saw the conversations a bit earlier from Blink and the manufacturers of batteries. And of course, we know Tesla and the automotive industry that's made that shift. CAE is doing that work right now with regards to electrification of a training aircraft. And that's about the storage capacity of a Tesla. That's about the amount of batteries that we're putting, but we only get an hour of flight. So, I mean, the density isn't there yet today, but I would like to get your thoughts on batteries today and how batteries might play a role and alternate energies such as fuel cells. So, Anita?
So once again, it comes down to the size of the vehicle, the total amount of energy you need to be stored. So batteries are a great fit for passenger cars. They're a great fit for drones, but they're just not going to be a good fit for larger aircraft because with a battery, you need more energy, you need more batteries. When you have a fueled system, whether it's fuel into a fuel cell or combustion, all of the energy is stored in the fuel. So you will never be able to achieve the energy density you can in a fuel that you could in a battery. Just it's inherent to it. So that's the reason why it's probably better just to shift to that type of system. That being said, like I said, it depends upon the use case, but I think for fuel cells, it also has a challenge, right? Because hydrogen is a very lightweight element, so you have to store it either as a high pressure gas or you have to store it as a liquid. If you store it as a high pressure gas, your mass fraction of your tanks is pretty bad. It's like less than 10%. But if you stored it as a liquid, as obviously is used for launch vehicle applications, liquid hydrogen, liquid oxygen, then you can get to excellent mass fractions approaching that of, avgas, gasoline. So that's kind of, it really is a function of how you do store it in that sense.
And that's a really interesting use case because I wouldn't want to power up my car like they power up a rocket. Every time I go to the grocery store. So the challenge there. Todd, your thoughts on this? I think thoughts around batteries and fuel cells.
Yeah, I think obviously batteries, as you stated, probably get you a little, around an hour, depending on the design, the mission profile, things like that. You can obviously go farther. The problem with batteries, though, if you want to continue to scale up without massive advancements in chemistries, you're always carrying the same amount of weight. Whether it has energy in it or not, you have the same amount of weight. Today, you leave an airport, you go across the ocean, you weigh less than when you took off, right? And so there's an advantage to burning a fuel from that standpoint. Weight is always a very big player when it comes to how far you can go and how fast you want to go there. So I think batteries are going to have that. They're going to have their area, especially with eVTOLs. You mentioned it in your opener. We do a lot of work with a lot of eVTOL OEMs. And they are all battery electric at this point in time. You then can continue to think through that process about hybrid electric, right? Can I go electric propulsion, but I'm burning SAF or I'm burning hydrogen or I have a fuel cell that provides the electricity, right? There's always going to be a trade, and I guess the way I look at it is as you get further up into, let's say, passenger type aircraft and ranges, you're probably going to completely need a new aircraft. You're not going to have a tube and a wing at the end of the day in the very distant future, let's say 25, 30 years from now. You're probably going to have a different design. You're going to have potentially what we call a blended wing design, which is highly efficient from an aerodynamic standpoint. You can make it weigh less. You can develop tanks to hold, liquid or gaseous hydrogen. You can do all kinds of different things. But tube, wing, 200 passengers, the same design we've had for 50 years, probably not 60 years, 70 years, probably not going to be what we see in the future when we really get to where we need to be from a net carbon standpoint.
You talk about the transformation of the aircraft design, and we see that now with eVTOL, right?
Yep.
In many regards, the innovation that's happening now in the eVTOL market space is akin to what happened 100 years ago to the car industry. You had hundreds of manufacturers; they're all coming up with innovative designs, and that of course dwindled over the years as that matured. But the number of designs for eVTOL, whether it's the Jobies of the world, the Volocopters, and the hundreds of others that are working in that area, it's quite fascinating to see very different design approaches.
Yeah, there's hundreds of them, and eventually we're going to consolidate to some design that works better than others.
Very good.
And Philip, as we were talking about last night, my concern with going from fossil fuels to batteries is what do we do with the batteries? So I think we have a lot of technological advancements we need to make in batteries themselves. If they're going to, continue to be used in everything, we do have that issue of okay, we got rid of fossil fuels. Now I have, mountains of batteries that can't be used anymore. How is that going to impact the environment? How is that going to really, will it negate any goodness we got from, bringing down our fossil fuels? So I know that's something we're really working on. And I think the industry needs to work on is if you're going to use batteries, how do you make batteries better, more sustainable, rechargeable, and not just create mountains of used batteries?
Yeah, I mean, that's a huge thing from a circularity standpoint, right?
Yes, exactly.
You think of scope 1, 2, 3 from the standpoint of sustainability, and how do you recycle that, right? If you consume a bunch of carbon to produce it, and then it goes into a landfill, you're not actually getting to a net zero standpoint.
And not to mention the fact that if the whole planet goes to electric vehicles, that the sheer supply of lithium and the other rare metals that are required to get there, I mean, there's a limited supply, right? So there's a duality there of circular economy, be able to recuperate that from the batteries and probably do so more efficiently and more cost effectively in terms of doing that, and also eliminate the aspect of those mountains of wasted batteries.
I'd like to add my 2 cents, if I may. So
Yes, please.
Just so you know, I have 2 electric cars, so I'm not anti-electric car. However, I'm an engineer, so I think they're cool. But I recognize that electricity comes from somewhere. And the majority of it in this country is still made with fossil fuels. So until we're figuring out some new form of energy we don't know about, or we have more solar panels, wind, and I hate to mention it, nuclear, we are not actually solving the carbon problem by using batteries as a storage device. That's all they are.
Yeah, it's interesting. I mean, for years, Greenpeace was against nuclear, and when they realized the alternatives, well, I guess nuclear might not be all that bad if you look at it at a global scale in terms of source of energy. Yeah, that's probably a whole topic in itself.
You're about 50 miles east of the world's or the U.S. largest nuclear power plant here.
Oh yes,
yeah, and we export power from the state. Yeah.
So I just wanted to say one more thing because I'm obviously a fuel cell advocate. So one of the beauties of fuel cells is that it's basically a box filled with metal plates. So it is completely reusable, refurbishable, and it uses a very little amount of rare minerals. So probably like 2 to 3 orders of magnitude less as compared to a battery. So in a sense, that's a really good solution. And in California, where we're based and where I live, and I have a fuel cell car, we have a hydrogen infrastructure. And in Southern California, it's 100% green hydrogen, which means it's been produced via electrolysis using wind or solar, which is also ubiquitous in the Southwest. So that is a really nice solution because it's a synergistic solution where I need the electricity, but I also need more green energy to give me the hydrogen. So that's why Europe is really interested because they're able to have excess capacity on their wind farms, which can then go into an electrolyzer to make hydrogen, which is now your energy carrier.
That's a very interesting combination, right? Because it is the confluence of the use of hydrogen and the generation of hydrogen by these renewable sources, right? Wind farms, in Quebec, over 90% of our electricity production is green. So there's an opportunity there for green energy production as well. Let's step to the second segment in our discussion panel today. Economics of innovation. So it's great to have all these capabilities, these a long list of technologies they're coming on board. What's the business model behind that innovation? How do we adapt our business approach to fund that innovation? How should government and industry work differently to accelerate that capability? And Jim, I think you have some thoughts on this topic.
I sure do. Yeah. So, I'm 58 years old, and I was born with the promise of Apollo, which I sat and watched the first astronauts walk on the moon. And the promise of Apollo was that we would have astronauts that followed. They didn't. The last one that stepped on the moon was 1972. And here we are. We're talking about going back. So there was a whole generation of us who got into the space industry, who wanted to do things, but we were beholden to the government because it was essentially a nation state activity. The capital to do it and both financial and the human capital was too great for companies, individuals, any financial institutions to foot. What's happened is very interesting. So with the introduction of, I would say, microtechnology in your phones and the like, satellites have grown smaller. And because satellites have grown smaller, they proliferated. So we went from launching 50 satellites a year to last year was 3,255.
Wow.
So it's huge, and it's growing exponentially. So this innovation has driven down costs, it's driven down size. It's actually made space affordable by venture capital firms. So the risk of the enterprise is still high. Space is very risky. And so the amount of money that's associated with a given level of risk gets lower the higher the risk. So we now have the price low enough where you're starting to see private capital flood in. And this is the so-called new space race. At least that's what I call it. Some people call it new space. And this is the next generation of what's happening. So space is going to open for commerce based on what's happening now. And we saw something like $4 billion in investment money come in to the space industry last year. It was a down year too. We'll see a bit more as the years come back. The market's been very bad, but this is a thing that's staying with us, and the U.S. government in particular starts to see commercial now as a partner rather than sort of this play toy on the thing on the side, and they're looking to the commercial people to actually do things that the government used to think that it was their own rightful thing to do.
Right. Sonia, I think you have some thoughts on this in terms of industrial collaborations and satellites as well.
Of course. I think one of the things that we do at Lockheed Martin, and in fact for space, one of my jobs is to really look at all these new entrants, look at the new technologies, and see how we can help uplift them. And most of the money right now in space is still with the government. But a lot of our new entrants, a lot of the new technologies, they do not know how to work with the U.S. government, and they don't know how to apply those new technologies to the missions that we support. And Lockheed Martin and my organization is very tied to meeting with those new entrants and bringing that technology as fast as possible to our government and to our allies. But it's really critically important, and my organization is really out there looking at quantum computing, AI, always a good term, optical, all of the innovations that are going on right now. And in fact, even for AI, we use AI now, I'm sure all of you do, on a daily basis in our jobs. Yep. And some people are very terrified of AI, having seen the Terminator. But, what we do is, at Lockheed Martin, when we use AI on a daily basis, we use it off a Lockheed Martin intranet. It's not allowed to go and play on the Internet of Things. No. So that we know the data is correct. But, we use it when we do proposals, and we do those proposals over and over again. AI can generate that proposal in 5 minutes instead of in a month. And when we talk about affordability, it's those kind of applications that make us more and more affordable, not just going to even smaller satellites, but how do we get that technology to be cheaper? AI is a fantastic way to do that.
Yeah, and I guess if you use it, then that's sort of the de facto basis of all your competitors, right? So if you don't use it, all of a sudden you're at a disadvantage. So it's about embracing that capability, ultimately to drive productivity. It's the ultimate goal of using that capability, get there faster, fewer resources, and optimize productivity. On economics of innovation, I'd like to get your thoughts, Anita, because it's a startup. It's a tough market out there to start up your own business. I'd like to get your thoughts on how you see the economics of innovation.
I've got a very strong opinion on it because I spent the majority of my career working for NASA, 16 years. So I always worked on government projects, and I can talk to you the efficiencies and the inefficiencies of government projects. But the government has a major role to play in de-risking new technologies. So I was actually able to get my company seed funded by the United States Air Force. During COVID, I started the company. I'm a research technologist, so I'm good at writing technical proposals. And so I was able to get my company funded that way. And then we got a phase 1, we got a phase 2. And so we've largely developed our unique IP for our fuel cell thanks to government investment. And when you take a look at like small business, basically funding that you get, it's like a 20 to 1. So the government puts in $1 and then they end up getting $20 out of it because then we were able to raise private capital. So there's a tremendous role for government to play in kickstarting these new businesses and letting them do their thing and say this is what's necessary, but also making sure they're making investments in businesses which have governmental as well as obviously commercial use cases. So like Joby, for example, part of Agility Prime. Joby is $1 billion company. We're in the Agility Prime program now. And so I think it's tremendously important. And I think one of the reasons why space, I think, was so slow to innovate is because the government controlled too much. And it's only now they've taken they're no longer holding the reins and they're letting, commercial crew, right? And so I think there's definitely a role to play, but they also have to let the companies do their thing.
And I would, of course, protest that space has always been innovative. I mean, it's space is hard, as Steve Cottrell said, right? It's very hard, but, space has had autonomy since we put the first satellites up there. I mean, you put a satellite up, it's not coming back down for maintenance if something goes wrong. It uses autonomy, very innovative launch techniques, et cetera. So for me, yes, innovation has increased in space, but I think just being in space is innovative. So that's just a plug for my team.
No, very, very good. Is it different between civil and defense? I mean, the models there on the civil front. You spoke about SBIR's funding streams. There is there in a purely civil realm. Is it always about bootstrapping off of government defense programs, or are there also all civil programs out there that allow that funding? I think one of the aspects I know, Sonia, you mentioned is the collaboration you have with other players in the market, right? About going out and finding those small, innovative companies that can bring certain areas of complement to the overall solution space. And I know it's something that we're looking at CAE is because you can't do it all. You have to find the areas where you have strengths and identify the complementary partners in your supply chain, right? So,
and absolutely, and I think that's something at Lockheed Martin. We are very, very concerned with making sure that we have a very diversified and healthy supply chain. As other companies are perhaps going more vertical, or actually want to extend our supply chain and not just have them be suppliers, but have partners. Anita and I, let's be partners with your new fantastic technology. And how can I support your proposals? How can Lockheed Martin get behind you and make sure that you're successful, and therefore we're successful together? So I think that's something that we're very, very focused on. Is we can't do it all. So who out there is doing it and doing it right? And we want to bring them in and help make them successful.
Very good. Todd, Honeywell, of course, spans civil, spans defense.
Yep.
How do you deal with that? Is there crossover there where you're able to reuse developments and investments that you're doing on one side to cross over to the other?
Yeah, and that's typically, so the majority of government funding that we deal with in the aerospace industry comes out of the DoD, right? Or agencies within the DoD or DARPA or any of the, Air Force, Army, whatever else. And so you do the joint undertakings that you can do, right? You put your own money in, you get IP rights out of it, right? Yep. The government gets, a cost share. And so their dollar goes a lot further, and they get a product or a technology. We get a product that we can use elsewhere in commercial. And so, there is plenty of research that goes on that can go both directions, right? It could go in a space arena, or it can go in commercial aerospace, or many different areas. And I think, one of the other places that we look to for public-private sector sort of relationships are around technologies that are way out there, right? They're like bets, where you think you got something, but you don't know if there's a product out there. Maybe there's an application, you have an idea. For some, publicly traded companies, it's really hard to dump a ton of research money into something that may never come to fruition, right? So making that dollar go a little further, partnering with governments, partnering with startups, partnering with other people to say, if this works 15 years from now, this could be the market. But 15 years is a long ways away, right? And so trying to make your own company dollar or a government dollar go much further is the combination of the two, especially when you don't know where it's going. There's massive infrastructure needed. Capital deployment's huge. A single company, minus some high net worth individuals that we all know about, typically don't go after that alone, right?
Yeah, I'm linking this back to the first panel session earlier today, right? Where there's conversation around the roles of government, looking at the strategic vision of where these segments are going in 10 and 15 years from now, right? Because those are the sort of investments where there needs to be some degree of incubation and strategic direction that we as private industry, I mean, I know we ask for a payback in a matter of a few years. You know, if I showed up to our CFO with a plan for payback in 15 years, I'd get thrown out of the office, right? So there is certainly an aspect there that we need to see that sort of collaboration between government and private.
Well, I think and just one example, Honeywell has a quantum computer. We invested in a quantum computer research for the last decade plus. If we had set off to say it needs revenue in 3 years, we would never have a quantum computer. So that partnering, the ability we've spun it out as a JV with another company recently, a year plus ago. Now it's into its valuation mode and some other things that are going on. But had we not been able to leverage, public-private sort of sector funding, you would have never spent 10 years, 15 years trying to do that. And so, but today we have a quantum computer leading in various areas and algorithms and throughput. And so we'll see where that goes in the near future.
Fantastic.
And I think that's so important about those partnerships we were talking about. I mean, Lockheed Martin is not investing in quantum computing because we know, Honeywell is. We don't want to do that, but how can we support each other? So I think even, not just the new entrants, but even the established companies, how do we work together? How do we make sure we're not duplicating, but we're growing from each other and what we're each doing?
Fantastic. And actually, that sort of partnership and collaboration now means that Lockheed gets access to quantum computing. Honeywell now gets a better business case because now you have a larger market segment to eventually see about distributing that capability. So that's fantastic. I'd like to switch to our last segment, talk about AI and also other innovations. I don't want it just to be about AI, but there's, of course, a lot of things happening in the aerospace segment that is outside of those innovations that we've spoken about here. So AI is certainly becoming quite, as you mentioned, I mean, we're all using it day in, day out, whether it's Copilot, ChatGPT, some internal trained large language model there. What potential does it have in transforming the aerospace industry? And Todd, I had you on this. Maybe you want to chime in on that?
Yeah, and so I mean, from a potential standpoint, it's probably unlimited right now, pending regulatory approval and how you use it and what you do with it, right? So I think, as everybody's all aware, and you mentioned it earlier, right? It's in our daily lives, whether you know it or not.
Yeah.
You could be chatting with an AI today, trying to get help at a help desk somewhere, and not even know it, right?
Yeah.
So you have the day-to-day interactions. We are leveraging it, similar to you, as how do we get our jobs done faster and easier, right? That's a simple way. From an aerospace standpoint, if you think about commercial aviation, let's stick with commercial aviation, autonomy is going to be a huge thing, right? You think eVTOL, you train pilots. If you need to train 5,000 more new pilots every year for the next 10 years, how are you going to do that? Are you going to be able to find the pilots, let alone train them, right? And so leveraging AI to develop aids so you can have less qualified pilots, but it's still safe.
Yep.
Whether you have a pilot on board with a digital co-pilot that is an AI talking to a ground station, right? These are the things that will change going forward. Not because we don't want pilots. We always want pilots. There's not going to be enough of them. There's not enough people entering to support eVTOL, the growth in commercial, the growth in business, the growth in general aviation, all those different market segments. There's not enough supply. So you need an aid. That aid is going to come through AI. Now, whether that's deterministic AI that we all know and love, that's easy to figure out what it's doing and you can control it, to probabilistic or generative where, okay, don't let it loose because
you don't know.
Something might happen, right? So it's going to be a long, probably roadmap to how you get there, especially when you bring in regulators like the FAA, EASA, number of people where safety is paramount, right? For us traveling public, right?
No, that's actually an interesting mention there of EASA, because they published just a few years ago their policy on the use of AI in avionics and aviation. I think that's quite a visionary view there of looking at and dissecting the AI problem into what role AI plays in its application of avionics and aviation as a whole. I guess I'd like to touch on another point you mentioned with eVTOL. I mean, we see this today. The eVTOL market space is manned. It's piloted aircraft, right? So this is not going to be the drone that's just going to, autonomous drone that's going to come and, deliver your next iPhone to your house. It will be piloted, but even that it's a single pilot. What happens if that pilot becomes in some way incapacitated, right? So is there a backup system? Is the system going to be able to, is there going to be a co-pilot, to use Microsoft's term, is there going to be a co-pilot there that's going to take over and land the aircraft safely, or engage with a ground-based station that's going to be able to do that? So I think there's a lot of applications there as we look at these platforms that are inherently single pilot applications, right? Where you have to look at what the backup plan is, because it's no longer that physical co-pilot next to you.
Yeah, that's contingency planning, right, is one of the big things, right? So you're on a flight path, something goes wrong. The pilot's not skilled enough to do something about it. Who can take over? Can you push the go home button and hands off and you land safely and everybody's okay? Somebody on the ground. Or, we are already working on pilot state monitoring, right? Testing it out in various locations and applications. So that's a big deal. How do you know somebody's asleep, in control, not in control, whatever, right? And then what do you do about it when that occurs? The auto industry is leading the way in this, by the way. The autonomous, I can take my hands off the wheel. It knows whether you're awake or not now in the latest generations. If you look at the new BMWs in Europe, you never have to touch the wheel like Tesla always wanted you to touch the wheel to make sure you were awake. They don't need to do that anymore.
Wow.
And then if you apply that to, deep space and astronauts, the further we travel, you need AI as a partner. One, not everybody's going to be awake 24/7. So who's guiding the spacecraft, but also in those, when an incident happens and you've got to make a decision faster than a human can make a decision, AI as a partner, I think, is really important, that we think of it that way versus AI taking over.
As long as they don't call it HAL.
You were reading my mind.
HAL, I think HAL is misrepresented,
Good intentions.
So I'd like to add a different perspective to this. Not that I disagree with anything that's been said, but the way I think of sort of history, if you go back even 25, 30 years ago, the amount of information that was available to the average person was much more limited than it is today by virtue of the internet. I call my old Encyclopedia Britannicas my 1970s internet, right? And when that became a thing, and we have this knowledge proliferation all over the world, that was really kind of the first phase of it. And I think in 200 or 300 years, when people look back, they're going to see this time to be the information explosion. And I think we're just in the infancy of that. And when you look at space systems in particular, I think that's the next generation of information explosion, because we're able to put things in space that tell us a lot more about what's going on in real time on our planet, move information around the planet in no time. If nobody here has had Starlink, you ought to try it sometimes. It's an amazing system. It blew even my mind. And the cost of that is really revolutionizing terrestrial networks. So for example, Starlink can push a gigabyte for 20 cents per gigabyte, whereas terrestrial networks are about 70 cents a gigabyte. You get up to some of the legacy Hughes satellite networks, they're $3, $4 a gigabyte. So the future from space alone is going to be this massive amount of information. And the way I look at AI, and I'm a user of it too, I actually use it to help write books instead of proposals. My proposal days are done, thankfully. But, AI takes a lot of information and transforms it into something useful.
Yep.
And so that's been the problem with so much of this data. There's a lot of space startups for imagery, for example. Planet's one of them, and there's so much imagery that comes out, nobody can really use it. So a lot of that imagery just sits. And with AI, we actually stand a chance of turning that information into decision quality information. So what do you think of space systems? Either you pass bit through space, or you have photons and you turn that into decision quality information. The photons are what you observe, right?
Right.
So AI is going to be central to that.
But I think that just like when we were doing data fusion with AI, the biggest issue is there's a lot of information out there.
Yep.
Not all of it is true. So I think that's what we have to be really, really careful about with AI is how you use it, what information you feed it. And we've all heard the stories about, I asked AI to make a medical paper off of what it finds on the internet, and it comes up with some fantastic paper. And all the references are made up as well. Because that's what you asked it to do. You may asked it to write a paper with references. So I think it's just, Jim, I agree with your point, but I think we have to watch what information we're feeding the AI, because I think right now, even in across the world, we kind of have Goldie mentions facts. We have different views of what the facts are, and we always will. So how do you feed AI and make sure it's getting the facts and getting the right data to make those action driving decisions?
Right, very good.
So I have a contrarian or a controversial view here, perhaps, on AI. So I am a commercial pilot. I fly small aircraft. I have a massive pilot community that I work with. And my fear, I'm also a huge science fiction fan. I love dystopian science fiction, is that we will become very lazy if we rely too much on these things. And in the context of being a pilot, when you have a failure of a system, an electronic system like, 737 MAX, if you aren't good enough of a pilot, your plane will crash. So AI doesn't solve the problem of making you safer necessarily. It can certainly alleviating cockpit workload is a good thing, but it will unfortunately probably result in less trained people. Like, for example, many people can't parallel park a car. They just can't, right? Because they don't have to, because the car does it for them. So just like in the movie WALL-E, where all the human beings became lazy, sitting on their seat doing nothing, I am worried about that. And I see that with my students, because I teach undergrad and graduate students, and now they're becoming lazier because they just put it into ChatGPT. So I am concerned about it just from a philosophical perspective, right? So we have to be really responsible about how it's implemented, and it shouldn't be done with the motivation because we're cutting costs. That's why we should do it. We have to think about the overall societal implications of it.
Right.
So.
And it's just so excited. I mean, there's a lot of studies on the fact that now that we have GPS and all the Google mapping, part of our brain is dying because we don't know how to read a map.
Don't know how to go from point A to point B anymore. If you turn GPS, I can't remember anymore. I mean, I used to know all the paths in my hometown, right? Right. And I don't think that's going to ever come back if I keep relying on the GPS. From an AI perspective, CAE just chiming in on this topic. We train pilots, and we use AI as a means to help us in assessing the pilot competencies. And that's an interesting application. So it's back to pilots, and the pilots is still in control. It's how to make sure the pilot has now been properly trained. Do they have all the right competencies and proficiencies to be not only successful in their careers, but also obviously safe, and the other metrics there that are critical to a good pilot. Fascinating. I think we've got just a few minutes left. I'd like to talk about just briefly on other innovations. I know conversations about additive manufacturing. Sonia, I think you mentioned additive manufacturing that we discussed? Maybe you have some thoughts on that.
Yeah, and I think additive manufacturing, we have a big focus on that at Lockheed Martin. Our customers have big focus on it. I think the interesting thing about it, just, mentioning the human brain and what our engineers have to know, you have to design for additive. And I think that, and Todd, you'll know this, part of the issue we've had with additive is, can you take this thing I already have and do it in additive and make it additive? And you're like, no, I need to design it for additive. And again, that's that we've got something that's helping us, something that makes things more efficient, cheaper, but that human brain on how to actually design it is a necessity still.
Yeah, and we've focused on that. We have an additive lab, right, where we leverage this day in, day out. Typically, it's for tooling and development. When it comes to production, different things come into play. It gets a lot harder to get those parts certified in a commercial environment, because you got to prove safety, you got to prove reliability, you got to prove damage tolerance, you got to prove fatigue life, a number of things. Yep. And without all the material properties that we all rely on today, day in, day out, to design stuff in a standard method today, don't exist in certain material incarnations with additive. And so It's tough getting these things into a production standpoint, but it does help out tremendously. I totally agree on the design for additive. We've been moving down that path for a very long time.
Jim, your last thoughts on that?
Yeah, so I just wanted to give you a practical example of the power of additive manufacturing. So we buy our engines, our rocket engines, for our first stage and second stage from suppliers. So there's legacy suppliers, I won't use names, but the equivalent engine that they've come to us and tried to sell it $10 million each, which is, you go back to the 90s, that was what was charged.
Okay, right.
Our modern suppliers, $500,000 and under.
Holy cow.
Yeah.
That's a 20 to 1 reduction.
Because they're additive manufactured. The legacy suppliers are still machining them like we used to do in copper plating them and all that stuff.
That's almost the Ford model, right? Applied to mass manufacturing.
Model T. Yep.
The Model T. We just have a few minutes left, and I do want to leave the panelists each a minute, perhaps, to go around and final thoughts coming off of this panel. So who'd like to go first? Anita?
So I will say that what's so nice about the energy space is that whether you're a government customer or a civilian customer or an individual, customer, you all have the same goal in mind, right? Which is to reduce your energy, reduce costs, and be more efficient. So I do think that it almost doesn't matter if your use case is civilian or governmental, or fully on commercial, because you're trying to reduce costs and reduce emissions. So there's so many synergies there, which is good. And so when you couple the energy sector to the transportation sector, now you're just making that even better, right? Because you're just reducing all sources of emissions. So I think it's actually a huge opportunity, and I only see synergies. And then I have one funny aside, which is kind of related to something we said before, which was we actually have a Formula One electric air compressor in our aircraft because it was so high performance. It was optimized for Formula One. Like, oh my God, this thing's amazing. We can fly up to 25,000 feet with this air compressor. You have to suck in air for the fuel cell to operate. So there's ways for things to go the other direction too.
Oh, interesting. Fantastic. Jim?
Yeah, so when I talk to non-space crowds, I like to put things in perspective. So if you were to go back 400 years and you were standing on the shores of Spain, you'd see the galleons going to the New World. And people would see them come back with gold, but they had no idea. Nobody could imagine what the New World where we're standing today would be. Just no ability to even imagine that. Nobody's smart enough. We're there today with space, right? We're in the very infant stages of exploiting our ability to do things in space. And so the future, we don't really know what it's out there. We're still in the stage of building the infrastructure to go exploit it. And so when you look at what's happening in space, if you look at it in that perspective, you begin to understand why, financing, we talked about it being government and the rightful role for government. It transitioned to private financing in part. That will continue, I think, because the economic exploitation of it will be great in the future, and the nations that do this will be on the cutting edge of the economic sphere.
Fantastic. Sonia?
And really, to Jim's point, we don't know the future. We did at Lockheed Martin create a Space 2050 vision. It's probably 80% wrong, but it gives us a point to go towards. I mean, manufacturing in space, a space economy, living on the moon, living on Mars. And from that, we can back up and say, what do we need to innovate? What do we need to do? Maybe it's a very engineering way to look at the problem, but, we've got that plan for, the space economy is coming and we have to be ready and we have to start now.
Right. Todd?
Yeah, and I think, if I just talk about the commercial, aviation industry, right, it's probably, we know where you want to be, right? Net zero, very efficient, everything else. What it will be is going to be completely different, probably. It's very difficult to pick, who's going to win, what's going to win, what technology is going to win. But I will say, over the last, 28 years of my career, I think we are at an inflection point of innovation, potentially driven by AI. And I think it's just going to accelerate more and more, and it's going to go into space. It's going to go into commercial aviation, into defense. And so I think it's a very interesting time to be in aerospace and defense, as we really transform the entire industry and see where we're going to go, whether it's autonomy, sustainability, navigation, communication, aviation, right? It's just it's a great time to be in the industry.
It's fantastic. I mean, it's, I guess, back to some of the points that were made a bit earlier about agility, right? Because we don't know. All this stuff is coming. We don't know exactly what order, but it's all coming in some way, shape, or form. And those will all combine together, I think, to potentially accelerate even more. So the ability to be agile, to be able to embrace and to be able to adjust based on those market segments. This has been a fascinating panel. Thank you so much to our panelists for this session. And certainly, if you're part of the networking session later on today, please come by and meet our panelists. Thank you very much.